Hey everyone, welcome back to another Teach LA Learning Labs crash course. Today we're going to be talking really quick about Firebase, which is an excellent solution to pretty much all your application needs. But more generally, I'm going to be talking about relational and non-relational databases, otherwise known as SQL versus NoSQL, or relational versus document-based. There's a number of ways you can describe the issue. But I'm going to be just kind of giving you a nice flyover of all the database types that we've got currently in the industry, and also how you can use Firebase and set up Firestore, which is a document-based database to use in your application or your software. Great. You also might notice that we've bumped the production quality a little bit. I currently have the ability to change between scenes. Anyways, just to kind of dig right into it, first off, I threw out some pretty interesting terms there. Relational, non-relational, document-based, SQL, all these very foreign terms if you're not familiar with databases. So, really quick, I'm going to just break them down. So, what is a relational database? Well, a relational database is what you might think of if you were to look at an Excel sheet. Now, here we're looking at my particular Excel sheet, which only has one entry in it. It's got an ID, a name, an email, and a password field, right? And in each of those fields, I have a particular value. In this case, Matt is my only user. But that's okay, because Matt's a great user. And you can see how everything is organized. And if I had some more users in here, maybe I was in here. It's not my website, but maybe I was in here. And all my passwords, by the way, would not want to be stored in plain text if I were doing this in an actual database. But I would have a number of rows here, and each one would represent a particular user or some particular document, things related to them, things of that nature. And you can imagine it would get pretty chunky, pretty fast if my application had, say 1 million users, right? In any case, this is what a traditional relational database can be thought of as. Now, what are some relational databases? Well, I'm glad you asked. The most popular one, or one of the most popular ones, is probably PostgreSQL, right? Now, what SQL is it's actually just an acronym for Structured Query Language. It's just the language you use to query through your particular database when you're working with a relational one. You can think of it as a complicated Excel formula, or actually a more easy Excel formula. It uses a lot of English, and it's pretty easy to get the hang of. But in any case, this is what a relational database example would be. We have a link to their About page here in our README, and you can just read a little bit about them. They've been around for a very long time. Relational databases have been the industry standard for a long while, but document-based is making quite the debut in the past, probably, I want to say 5 years. And what is the other type of database I talked about? Well, it was document-based. And if you want a more concrete example, let's take a look back again. We can look at our terminal. So I've opened up a terminal right here. It's just node is what's running. And I've declared a variable Matt. Now let's take a look at Matt as a variable. We have a few fields going on here, right? We have his name, we have his email, and we have his password. Exactly what we have going on in our relational database. Now, where are things different? That lay in the actual way that things are laid out. Instead of being a table, right, in which we have rows and columns, we're looking at a JavaScript object. Now, this is how document-based databases work. All of their documents can be thought of as a traditional JavaScript object. It's a number of key value pairs associated to a name. Now, in this case, the name would be the ID of the document. We can set the ID to a string if we want to, but generally speaking, it'll be something randomly generated. Now, let's get back to our web browser. Because what is an example of a document-based database, I hear you asking? Well, that answer is quite simple. MongoDB is a very popular one. They're used by, as you can see here, millions of developers to power the world's most innovative products and services. Now, I'm not trying to make this into an advertisement for MongoDB, but they are very popular. You can see here they're used by a number of some of the largest companies in tech right now. But What's the one we're going to be focusing on today? Why is this video titled Firebase? Well, that's because Firebase is made by Google and it has a lot of features that you won't get out of something like MongoDB. So, really quick, let's just take a look here. Why would we really want to focus on using Firebase? Well, it's really, instead of a database, more like a pseudo backend. Now, I use this same verbiage in the README, but the reason I say so is that it's not just a database. It offers a lot of other features for your application, many of which you might not even need to use. It offers machine learning features. It also has cloud functions. You can configure it all remotely. But some of the more important elements that it takes out of your hands are security. Now, when we're working with users and passwords, if you recall back at the Excel sheet, right, or even in the Node one, you can see our passwords are stored in plain text, same with the emails. Everything on there is just kind of very insecure. Now, luckily with Firebase, all of that is managed by Google. When you're creating a new user, when you're logging in, you don't really have to worry about any of that. They have functions for that. And speaking of functions, they have those functions in a variety of languages, not just JavaScript, not just C, but they also offer it in Go, they offer it in Python. They have a number of bindings for a variety of languages. It's very easy to work with Firebase. So let's go ahead and let's make an application that uses it. Why not, right? So first off, what we're going to want to do is actually create a project. Now, I'm on my school account, so I have no projects going on here, right? So it's a fresh start for all of you at home. And I'm sure that everyone's in the same boat now. So let's get started. First, I'm going to go ahead and create a project. Now, you can see here that it just has some random ID that we generate. So let's just say I generate a learning lab, right? And you can see here it gives this unique identifier for our project. Okay, so minor hold up just happened there. Turns out that if I were to do this on my student account, then it would have to be housed under the UCLA organization, and I'm a bit scared to do so because I don't know if that would get me in trouble with admin. So in any case, let's go ahead. I'm on another account now. I'm going to just go ahead and create the same name, accept the terms. It'll ask you if you want to use Google Analytics with your project. I don't really need them, but if you wanted to, take a look here, they offer A/B testing. They offer reporting for all of your things, traffic. It's very helpful. But in any case, we're going to create the project. If we check back here, our project is ready. I'm going to click continue, and here we are. I don't want to sign up for new plans or what have you, new news. Anyways, if we take a look at our project overview now, you'll see that we're on the Spark plan, which is free. You don't have to pay at all. And there's a few tabs over here on the left. Now we're going to click on Develop, because that's what we're going to be doing. And we're going to click on Cloud Firestore, which is where we can actually set up our document-based database. You can see here you can just create a database. I'm going to just go ahead and do whatever. You have two options here to start it in production mode, which is where all of our data, all of our reads and writes are private. I won't explain these in this lesson, but these are things called rules for the actual Firestore database. They basically just dictate who can read and who can write to it, and who can modify what parts. So, for our purposes, we want to get going real quick. We're going to start it in test mode, which allows all reads and all writes for 30 days. After you set this, you can also choose the location of our particular database if you want to focus on latency for your users. I'm going to just choose US Central, also because it has multiple servers across the country. Excellent. All right, so once it's been loaded in, you can take a look here. We should have our Cloud Firestore instance in our particular database here with a particular unique ID. There won't be any collections or any documents, but that's okay. We're going to create them when we write some software, which I am going to do right now. I mentioned that I was going to show you how to write a basic application. Easy enough. We're going to go ahead and just follow along with the quick start guide that they provide us, and then we're going to tweak it a little bit to do something that we might be interested in. So right off the bat, we need to install the bindings for it. Now we're going to be working directly with the database, so I'm going to use Firebase admin. Now what this does is it allows you to use your application to gain control over all aspects of your application, quality analytics, all that stuff. You could mess with any of it. So it's not ideal if you want to keep things pretty tight, but it is great if you're writing a tool to help other people or to help your dev team modify things on the database on a large scale. Great. So we're going to go ahead and install it. If we check back here on my code editor, I'm going to open up the Firebase folder. I'm going to go over to, hopefully you guys can see the terminal. It might be a little bit tricky to see. In fact, actually, let me make this a little bit easier for everyone. So I'm going to just do this. There. So now all of my typing is to the left of my head. All I did there was I just created a new variable, or I modified the shell variable. Anyways, we're going to change directories to Firebase, and we're going to change directories to our sample app, at which point we will install as a dependency Firebase admin. You can see here it's already in my dependencies folder here for the package.json, but we're going to do it again. Excellent. Okay, so things are downloaded now. We have our Firebase admin on board, and we're going to go ahead and import it. I'm going to do it with an include, or with a require. And now what we need to do is initialize our connection to the Firebase instance, right, to our particular project. And the way we're going to do that is by creating something called service credentials. So what we're going to do is go to service accounts under our settings, which allows us to create a set of keys that are used by one particular application in accessing the database. And what we're going to do is generate them for node, generate the key, save it, and now I'm going to switch back to our editor, and I'll go ahead and drag in our Learning Lab credentials, which you should not be able to see right now. But here's something you can see. We have a set of example credentials right here. So your credentials should look something like this. Excellent. Now that our credentials are in our folder, what we can do is initialize our application. So the way you do that is by making a call to Initialize App from our admin library. And this is going to take an argument which is an object of options. It's going to require a credential, and it's also going to require a database URL. So let's go ahead and get those prepped. The credential, in our case, is going to be a JSON file that we have on our disk. And the way that we can include that is just with a simple require. And I'm going to go ahead and just include the whole thing there, which I should really rename. I renamed it just now. Sorry for the jump cut. And then for the database URL, if we take a look in our browser, it provides it to us. In this case, it's going to be Learning Lab 7.1, the unique identifier, right? So let's go ahead and copy that, bring it back over to our editor, paste it right in. And with that, our application will be initialized, which is perfect. The next step that we need to do is create a connection to our database. That's going to be by declaring admin.firestore. Firestore because we are working with the Cloud Firestore, not the real-time database. That's a little bit different, and I might do a crash course on that later on. Great. So switching back to the editor once more. Now that we have our database, we can work with the actual interface of it. Now the nice thing about working with Firestore is it provides a very intuitive interface for working with our documents and our collections and anything in that database, right? So when we're talking about a particular collection, easy enough, we just make a call to db.collection. And if we want to get a particular document from that collection, easy enough, we just call doc on the collection. And if I want to do something to that document, then I can just work with it as any other. I could create it, I could delete it, I could get the data and put it in an object that I could then use programmatically. I could test if it's equal, and the one that I'm going to be using right now is set it to something. I'm going to set it to some random data, and we're going to create a test field. Let's say test num is 2, and we'll say test string is hi. Great. So with that, this function, or this particular file, if we ran it under node, should give us a document in our database with the ID test, and whose contents are set to 2 and hi. So let's test it out. The way we're going to run it is pretty simply just node index.js. Something I just noticed is I actually missed this just now. It's admin.credential.cert based on the actual file. There we go. Sorry about that. So now if we run this and we take a look back at our Firestore, we can monitor it live and we can see that a test document's been created in users with the keys testNum and testString, both of them set to our expected values. Pretty handy. So now that we're familiar with how to work with the interface, let's write a tiny piece of software, right? So in my example, I'm actually going to just follow along with the example here. So feel free to code along with me. What we're going to do is we're going to create a node application that takes in from standard in and then writes it out as a memo in our database. Now you might want to do this if you wanted to write some documents, right, or mutate data midway through before you write it to your database. But a more general and more realistic application of this would be if you wanted to use it as part of a chain of behavior. Now, if I were working with a database in my backend, right, this would be pretty similar. I would be reading not from standard in, I'd be reading from a request body, and then I would be writing to the database. In any case, what we're going to do for any type of file system operation is use the FS library, which is provided by Node. And what we're going to do is really quickly just read in straight from standard in. So I'm going to create a constant, which is input, and it's going to be fs read file sync, meaning synchronous, and we're going to read the entirety of the file descriptor 0, which is traditionally standard input. And we're going to convert that to a string. Great. Then what we're going to do is write this straight to our database. So with what we've learned in mind, what we can do is address a particular collection. I'm going to say that it's the memo collection. And then we can address a particular document. Now, we want to create a random UID for this document such that it doesn't have any collision with others in that particular collection. Luckily, Firestore actually takes all of that out of our hands. So when we call doc with no argument at all, you can see here, we get a randomly named document. And it'll be a unique ID, and that'll be used as the ID. So we won't have to worry about naming things or checking for collision, which is nice. So we're going to just go ahead and set, which creates the document if it doesn't exist yet, and we can also use it to merge things, but we're just going to use it because we want to be able to create documents. We're going to set it to the value of input. So we'll create one key content, and we'll set it to input. Nice. Now, the beauty of this, if you check the documentation here, is that it actually doesn't return a Boolean or some kind of error message if something goes wrong, but it returns a promise. Now, if you guys remember from our talk about asynchronous programming, you'll recall what we can do with promises, and the answer is chain. So we can then take our particular response on success, and we could log it, right? So let's say I want to log success, and then I'll just put in the response there. And if I catch an error, then I want to log it as an error, and I'm going to say encounter an error. Whoops, error. Nice. So now what we have going on here, if we break it down, is a very simple piece of software written in 20 lines that will take input from standard in, read it all, then write it directly to a database, which is not on our computer. And then it'll log if it's successful and if it encounters an error, which is nice. So let's go ahead and test it with some input. If you're familiar with the command line, you'll be familiar with the echo command. Now this end flag that I'm using here just removes the new line character at the end of the input. And I'm going to echo some random string. Hi, Matt. Just like that. And you can see here, since we don't have that new line character, it just blends right onto the start of the next line of input. So let's clear that out. And let's try recording that as a memo for ourselves in the database. And we're going to pipe it. That's what this operator does here. It takes the output of the previous command and pipes it into the next command, which will be index.js. So if we run it, then we can see that there's success, and it just prints it out as an object. So we're not going to get anything super useful out of that. What we could do instead is use, say, a property of the object, such as the timestamp, which will give us a little bit more verbose output. And if we take a look in our browser, we will now have the memo collection, and in it, a randomly generated UID for a document whose content is Matt. Hi, Matt. Likewise, we could do this with any kind of input. We could change the fields just to demonstrate the fact that these documents don't need to be the same. I'll do this. I'll just say str. If we run the same thing, and just to show you guys what I did there, forgot to switch out. I changed the key to str and then I ran it again. And if we take a look in our browser, there is another document, and you can see here that it's not the same key. That's one of the benefits of having a document-based database. Very handy. So that kind of does it for the super quick tutorial. In terms of things that you can do with this information and things that you can do to work with the Firebase system that we've got set up here, is you could, instead of reading from standard in, read from a request body using something like the Express server that we wrote, I want to say, 4 weeks ago. Another thing that you could work with is potentially try mapping instead of from a string into JSON, at which point you could just write it straight in like this. Or another thing to play around with is how you could mutate the input and then bind it to certain things. Another thing you can use is the get function, right? So if I wanted to instead get the particular document from my memos, right? Then let's say I would do it like this. I would provide the input as the ID of the document, followed by the get function. Then, on success, we would say r.data, which provides us the data for it. And we could log that data right there. So now what we've done is we've transformed our piece of software that once took memos into a piece of software that retrieves them. And just to explain what's going on here, the data function is bound to a document reference, which is retrieved from get. And since we're promise chaining, we can do this. And what it does is it returns a JavaScript object with all fields of the document. So just a lot of ideas that you can play around with here. This is obviously just scratching the surface, and there's no way that we could get through all of it. But if you want to check out all of the resources that we have in our README, there should be a lot that are pretty handy, such as the Quick Start Guide for Firestore, which helps explain away some of the details that are going on right here and why we need to do them. You can also check out the entire documentation for Firestore and the entire Firebase admin suite, which is incredibly handy because of the fact that these are all very intuitive, and having a good grip of them makes life very easy for you. You can do a lot of very fun things with functions like set or like create, because you can leverage overriding with set. That's pretty handy. Just a lot of ideas again. Okay, so that does it for this particular video. Hopefully you guys were able to learn a little bit about relational databases, document-based databases, kind of what the differences are there. Hopefully you also were able to pick up on how this interface is intuitive and why document-based databases are kind of in the limelight, as it were, because of their intuitive interfaces and the way that it just makes more sense when you're working with object-oriented programming. And hopefully you were just able to learn something new from this all. From here, I recommend that you play around with this particular 19-line little program that we've written, just to experiment with the extent that Firebase can help your project. And also, I encourage that you take a look at all of the features that Firebase offers you. Again, we just focused on the database today. However, you can do a lot more with Firebase. As a matter of fact, Firebase is so sufficient that you practically don't need a backend when working with it. In any case, that's going to do it for this video. I hope you all learned something new. Take it easy.